All right, everyone, welcome back to the Chemistry Girl. Today we're going to do some practice problems, this one, to help us learn how to balance chemical equations more efficiently. So, this first one says aluminum metal burns in air to produce aluminum oxide. So, the first strategy that I like to use is I like to give each element a color. So, in this case, I'm going to draw aluminum in red, and then I'm going to draw the oxygen atoms in blue. Now, I hope that you're noticing that I'm actually connecting the oxygen atoms together. So this is two different oxygen atoms bonded together. And the reason that I'm doing that is because there's a little 2 here. That little subscript means that those two oxygens are bonded together. I also like to draw a dividing line over the arrow to show me very clearly where the reactants are and where the products are. Now, I'm going to take my red and my blue dots and I'm going to draw them over here. And remember that I'm going to draw 2 aluminum atoms in red and I'm going to draw 3 oxygen atoms in blue. And then I'm going to connect them all together because those little subscripts indicate that the atoms are actually connected together. If you don't know how to connect them together, that's fine. The most important thing to know is that they are actually bonded together. They're all connected, and that's because these subscripts tell me that they are all connected together. So now that we have an accurate particle diagram here, what we can see is if we count the aluminums, I have 1 aluminum on the left, and I have 2 aluminums on the right. I also have 2 oxygens on the left and 3 oxygens on the right. So it's pretty obvious that this equation is not balanced, and so I need to go ahead and balance it. But I just want you to remember, doing something like this, such as adding another oxygen bonded to this molecule over here, this would indicate that I'm actually changing this number to a 3. And we actually can't do that because then we're changing the identity of that substance. So I'm not going to do that. That is tempting to do, and a lot of people do try to do that. But I just want you to know from here on out, we can't really change the subscripts. So instead, I'm going to put some blanks out in front. And we're going to have to figure out what are the numbers that go out in front. We're not going to change the subscripts, but we are going to change the coefficients. And so what I want us to focus on right now are the oxygens. I always like to start with the oxygens first. And I see that I have 2 oxygens on the left and 3 oxygens on the right. And so what I want you to think about is what is a common multiple of 2 and 3? So if I multiply 2 times 3 together, I get the number 6. So I'm wondering, is there a way that I can get 6 oxygens on the left? And then can I also somehow get 6 oxygens on the right? And so if I attempt to do that, what I could do is instead of trying to bond more things to this molecule, I could just draw 2 more molecules. And remember that these things are bonded together. And when I do that, now I have 6 atoms of oxygen on the left. And so then another question would be, okay, well, let's see if I can get 6 oxygens on the right-hand side. So what I'm going to do is I'm going to draw another molecule of aluminum oxide over here on the right-hand side. And when I do that, just remember that these things are bonded together. Now I see 6 oxygen atoms on the left-hand side. And actually, I have 6 oxygen atoms on the right-hand side. So let's go ahead and count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that actually balances my oxygen atoms perfectly. I'm going to go ahead and erase my check marks. And so now all I have to do is come back to my aluminums. So just so that we know, now I have 6 oxygens on the left and 6 oxygens on the right, and so that one's perfect. So now all I'm going to have to do is go back and balance my aluminums, or my red dots. And so I see on the right-hand side, I actually have 4 red dots now. And so on the right-hand side, I'm going to draw 4 red dots in total. So I have 4 in total. What I'm not going to do is I'm not going to bond them together. Because if I do that, if I bond them together like this, boing, 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 then I'd have to put a 4 down here at the bottom. And I don't want to do that. I don't want to do that. I don't really even need to do that. I'm just going to draw dots here so that I have 4 in total. And to show that I have 4 in total, I'm actually going to come up to this orange area and I'm going to change the coefficient to 4. And here, to show that I have 3 of these in total, I'm going to put a 3. And over here, to show that I have 2 of these molecules in total, I'm going to put a 2. And so now what I can see is this equation is now balanced because I have the same number of atoms on the left as the right.